Ever wonder how electricity gets from a power plant to your home? In this quick and simple video, we break down the entire process, from energy generation to distribution. Discover how turbines, transformers, and transmission lines work together to power your lights, devices, and more. Perfect for anyone curious about the science behind electricity. Electricity is primarily generated in power plants that use different types of energy sources. Fossil fuels, such as coal, oil, and natural gas, are commonly used. These plants burn fuels to create heat, which turns water into steam. The steam spins a turbine connected to a generator, producing electricity. Nuclear power also plays a significant role. Nuclear reactions generate heat, turning water into steam that drives a turbine to produce electricity. Renewable sources are increasingly important. Hydropower works by water flowing through a dam, spinning a turbine. Wind power uses wind turbines to harness the force of the wind to spin a generator. Solar power relies on solar panels that convert sunlight directly into electricity using photovoltaic cells. Generators operate on the principle of electromagnetic induction. When a coil of wire moves through a magnetic field, like in the spinning turbine, it induces an electric current. Step-up transformer. Electricity is generated at relatively low voltage, typically 11 to 25 kilovolts. To efficiently transport it over long distances, the voltage must be increased. Transformers are used to increase the voltage. A step-up transformer does this by using two sets of coils, primary and secondary. The secondary coil has more turns than the primary, increasing the voltage. Transmission lines. High-voltage electricity, sometimes as high as 765 kilovolts, is transmitted over transmission lines. High voltage is necessary because it reduces the loss of electricity due to resistance as it travels over long distances. These lines are supported by large steel towers and can stretch hundreds of miles, connecting power plants to substations in cities and towns. The electricity flowing through these lines is alternating current, or AC, because AC is easier to transform between voltage levels and can travel efficiently over long distances. Step-down transformer. As electricity nears its final destination, its voltage needs to be reduced to safe levels for local distribution. A step-down transformer does this by decreasing the voltage. For example, electricity might be stepped down from 345 kilovolts to 11 to 33 kilovolts for local distribution. This transformation happens at substations located near cities or neighborhoods. The electricity now travels through distribution lines, which are lower voltage lines that deliver electricity to homes and businesses. These lines carry voltages typically ranging from 4 kilovolts to 33 kilovolts. There is often another round of step-down transformation as electricity reaches residential or commercial areas, reducing the voltage to the level needed by appliances, typically 120 to 240 volts. The final stage is when electricity reaches its end users: homes, factories, schools, or offices. In homes, appliances, lights, and electronics run on low-voltage alternating current, usually 120 volts or 240 volts depending on the country. Devices like TVs, computers, and lights convert electrical energy into other forms, such as light, heat, or motion, to perform their functions. The grid is monitored and controlled to balance supply and demand. When demand is high, for example, during hot days when many people use air conditioning, the grid may tap into backup power sources or redirect electricity from areas with lower demand. Smart grids are modern versions that use technology to monitor, predict, and distribute electricity more efficiently, preventing overloads and reducing waste. To prevent accidents, electrical systems have various safety features such as circuit breakers, fuses, and grounding wires. These systems help cut off electricity in case of faults or overloads, protecting homes and businesses. In summary, electricity starts at power plants, travels long distances through transmission lines, and is reduced to lower voltages by transformers so it can safely power homes and businesses.